because I'm not asking you a percentage, but what do I have to know first? I have to know what my total cycle time is, right? So let's see. My total cycle time is how many seconds in a minute?
1.2 seconds in a minute?
No, 60.
60 seconds in a minute,
Oh.
right? So if I have 60 seconds in a minute, and I am doing 24 breaths per minute, how many seconds do I have for that breath? 60 divided by 24.
It's gonna be 2 point something.
Okay, I know it's gonna be 2 point something, that's right.
Kind of like 2.12.
Okay, 24 goes into 120 5 times.
Oh.
So I have a 2.5 seconds for a total time cycle. Okay, so now I'm going to have to do compliance for 12 o'clock, and I'm going to have to do airway resistance for 12 o'clock in order to calculate out a time constant, right? Do I need to go back? Okay, where to, Mary?
From the beginning of that problem you just started,
Okay, so
the settings.
oh, so my time console just
So use so are the settings for 12 o'clock adequate to allow for 95% of the volume to enter the lung? Okay, so when I'm looking for percent of volume, I'm looking for a time constant. Okay.
Okay.
So to calculate a time constant.
So that is the key to doing time constant is percent of volume.
How many time constants I need? If
For
they
95%?
said 100% of the volume to enter the lung, how many time constants is that?
1? No.
How many percent?
5.
5. One time constant is only 63% of the time. We're always looking for a minimum of 3, which is 95%. Preferable, especially if you have somebody that's air trapping, would be 100%. Okay, but this one is asking us for 3 time constants.
Okay.
So now I'm going to have to take this data to calculate compliance and airway resistance to get a time constants, okay?
Which is those.
Correct.
Those thingies.
So
we have to memorize that chart and we'll be
so
good.
here's 12 o'clock, okay? My volume is 500 milliliters, right? Okay, so my calculation for compliance is change in volume over change in pressure, okay? Which is going to be our plateau minus P. Okay, so that means I've got 500 divided by 16 minus 5, right?
Where are you getting those numbers?
Right here, my data table.
Oh, plateau and peak. Okay.
For 12 o'clock.
So 12
Oh,
o'clock.
for 12 o'clock,
Plateau
okay.
is 16, my peak is 5, okay? So that is 11, okay? So when I do that out, $11 goes into 500
4
times.
44.
11 goes into 6 how many times?
5.
5.
5.
Okay.
2, 6, oh, 16.
You got it. Okay.
Yeah. I thought that was
Okay. Oops.
When do you stop adding the
Four
zeros?
So right
Enough.
now, I'm just gonna go over just one.
4 times.
11 into 5, 4.
4 times.
So roughly, my volume, or my compliance, is 45.4 centimeters of water, milliliters per centimeter of water. That's my compliance at 12 o'clock based on those factors, okay? Can I erase this bottom part?
Mhm.
Okay. So now for airway resistance, right? So I'm gonna take my PIP minus my plateau, and I'm gonna divide it by my flow, which has to be in liters per second. Okay, so when I look at 12 o'clock, my PIP was 32, my plateau was 16. So I've got 16 divided by, we already did our math earlier, when we converted 40 liters per minute, it comes out to 0.67 liters per second. Okay. So when I divide 16 by 0.67, I'll move my decimal 2 points. 67 goes into 160.
67, 160 twice.
2.
121, 134. 134.
1
Yep.
plus 134. So I have how many left?
6 and
2.
2.
2.
Okay.
Thank you.
I'm going to bring down the other 0 that was there. So 67 can go into 260.
4 times? Let's
So 4 times, it's going to be a
Probably
little too
3.
big, but that's
3.
So let's try 3.
67.
201. Okay.
Mm-hmm. 59.
Cannot be.
Then you add 0.
What is it?
I can't.
That's one wrong. So this.
I'm going to show you what we have to change in a minute. So 67, so 0, right?
Yeah.
Okay, so let me put the units back here. Okay, 45.4 milliliters per centimeter of water. And this is where a distractor would go in for an answer. I'm just going to explain that to you in a minute. This answer is 23 centimeters of water per liter per second, right? Okay. Centimeters match. We don't have a time in the other one, but do you see how this is liter and this is milliliter? If I was to multiply those numbers out, okay, the answer is going to be wrong. But what I'm going to show you is what a distractor is. Okay? Distractor is an answer that if you didn't do your math right, or you multiply 2 wrong factors, that answer is going to be there.
Right.
And you're going to think you're right. Okay? So, if I was to put down 45.4, which is my compliance, and multiply it by 23, which is my airway resistance, okay? 12, 15, 16, 12, 13, 8, 9, 2, 4, 1, 0, and I'm going to move my decimal point. I hope you would realize that your answer could not possibly be, okay? But what you will see in other problems is that they may have the decimal point in the wrong place because you didn't convert. Okay, so you do your math and you didn't convert and you saw this, you'd be like, yep, that's my one time constant, 1,044 seconds. Hopefully you would understand that just knowing that you must have done your math wrong, something is not right there, okay? Because we have to actually, to do our time constants, this has to be in liters per minute. So I have to convert 45.4 mils to liters. All I'm gonna do is move my decimal point 3 places to the left. 1, 2, 3.
You wouldn't do it first with the 500?
You can.
Oh, okay. I was thinking that when you were doing it.
So
Okay.
if you did it inaccurately and you used mLs here, you can easily convert it at the end.
Mm-hmm.
But if you didn't and you took this number and plugged it into your time constant, it's gonna be wrong.
Mm-hmm.
Okay, so they'll do other math problems like that on your test where you didn't convert a number and it may be the difference between 20 or 200 for a different problem. Okay, so that's what you want to make sure. So again, hopefully you would realize when you got that answer that that can't be right. Okay, so if this was instead 0.045, I know that I'm just going to move my decimal point 3 places to the left, right? Because that's what I did there.
1, 2, 3.
So my time constant is 1.04 seconds. Okay.
How much of this is on the test?
A good amount of this
Okay.
in one form or the other.
Uh-huh.
I know you have the first one for the volume, right? The second one, the peep and the plateau. What was the question for it?
Well, because in order to figure out a time constant, I have to do my compliance and my airway resistance, right? And multiply them together to get a time constant.
Okay, time constant, okay.
Okay.
Oh, okay, gotcha.
Oh, okay.
Okay.
Anytime you need to look for time
Time constant,
You
gotta
have,
do
you
both.
have to have
Oh,
compliance and
and
airway
airway
resistance.
Okay.
Okay? So, according to 12 o'clock, based on these factors, okay, one time constant is 1.04 seconds. So 3 time constants,
12, 1, 3.
okay, this is you're not going to come across this in probably real life. But, okay, so now let's go back to our original question. Okay, are the settings for 12 o'clock adequate to allow for 95% of the volume to enter the lung? The answer to that is, do I have, look at my eye time.
Oh, so yes. No? You're
I
getting
want 3 time constants. My 3 time constants comes out to 3.12 seconds.
Yeah.
What do I actually have as my,
Oh, that's the answer. Okay, one. No, it's not.
no, it's not even close.
But
More than that. 3
I have a
times.
question.
Yep.
So why do you look only at the eye time and not the, you know, the total cycle time?
So I just want you to see this. So whatever you want for inhale, for a time constant, you usually want for exhale at least, right? So if I have a 2.5 second, okay, cycle time, total cycle time. My I time is 1.2. What's my E time going to be?
2.5 divide minus 1.2.
Okay, so my E time would be 1.3.
1.3.
So if I change this and said, are the settings adequate for 95% of the volume to exit the lung? It's the same thing. You still have to calculate out your resistance, your compliance to get your time constant. So it's not just enter the lung, it's exit the lung, okay? So now, if I said percent of volume to exit the lung, in order to answer that, I have to know my total cycle time, what my I time is, and then I can get my E time, my exhale time.
So
Is there enough time for 95% of the volume to exit the lung based on this?
No.
1.2 seconds.
No. Okay, so now let's do some critical thinking. What can I change so I can get it that the patient has enough time to inhale and exhale?
The flow.
Plateau is what's measured in the lung, right? Peak inspiratory pressure is what's measured in the lung, right? Which is based off of your tidal volumes, right? Can be based off your flow. So if I manipulate some of these other numbers, so look at your big picture here. If I change any of these values, okay, what I can manipulate, okay, is my volume. I can manipulate my PEEP. I can manipulate my flow. So if I manipulate some of those numbers, then I can probably make that better, okay? But we're not gonna get there yet. Okay.
Are we gonna get to do that?
I'm a little confused.
When we get further on in ventilation, and we don't have enough background to start really changing stuff. Okay.
So Denise, it depends on the question to know which one we have to focus on.
Exactly.
If it's exit, so we're gonna look at the expiratory time.
Correct.
If it's inhaling, how
You
many?
wanna know the
what's
I
the
time.
You wanna? Okay, all right.
Yep. And to get either of those, if let's say I told you, let me do something different.
Joe, what was the question you just asked?
And my percent I time is 33%. So this is kind of from yesterday's lab, right? Okay, if that's all I had, I can still figure this out because my respiratory rate was 24, which means that my total cycle time is 2.5 seconds. So I'm going to take my 2.5 seconds and multiply that by
33%.
33%. So if that's what I had, let me do it over here.
Which is 0.33.
Yeah, exactly. So that's all the information I had, and I wasn't given a specific I time. So I have a 2.5 second total cycle time. My I time is 33%. So I'm going to multiply this by 0.33. So go ahead and multiply that out.
Okay, times 5. Oh, do it with the thing, or do it on the paper? Okay.
Try to do your stuff by hand if you
Yeah.
can, because
2.5.
test again, you're not using a calculator.
No, not a calculator, do it on the paper, she said.
3 times 2 is
Oh,
6.
good, smart, you're so quick. Oh,
So say that number again.
6.27.
6.27, that would be how many seconds your inspiratory time is. Does that make sense? If your total
Yeah.
cycle time is
How'd you do that that
2.5
fast?
seconds.
I didn't even get that answer.
Does that make sense?
2 times 15.
Okay, so this is where you have to think.
I got 0.825. That's not right.
8 point something.
Okay, so 33% of 2.5.
That's what I got. So.
Yeah, 8 point.
8.8.
Oh, I thought you said a different answer. Okay.
No, I said if I gave you a different way of putting in your I time, here's your percent I time is 33%. So now I have to do my total cycle. So 15.
75. Yeah. Yeah.
1, 2, 3.
3.
Okay. So if my I time,
You could do 0 under the 5.
what's that?
You put a 0 under the 5. Yeah, that's
Yeah, so it means nothing, just to fill the blank.
Oh, that's to hold the plate.
Okay. I'm like, missing something. Anyway.
Okay, I do my backward, that's why.
Okay.
Yeah, they do math
So that's-
different.
Yes. does somebody want to do that in the way you learned it? So
That's exactly how I learned it.
I got 8.25.
Yeah.
8.25.
No, but the decimal over
8.25
there.
can't be right
It can be right.
because
Oh, I
if our
didn't
total
count
cycle
the-
time is
okay,
2.5 seconds,
1, 2. This is
33% has to be smaller,
Smaller,
Mhm.
yeah. It can be
Yeah.
8.2.
so 1, 2, 3.
right?
That's
And
Has
fine.
to be
you
smaller.
count the decimal places.
Behind.
5 has
Behind.
1 and the other 2 have 2,
Two,
so it's
so it's
3
three.
decimal places.
Yeah. 1, 2, 3.
Oh, you got the other one.
Yeah.
Okay.
Yes.
Both.
1, 2, 3.
Yeah.
All right.
And again, on tests, you'll see a distractor where they're going to put an answer in that
Yeah.
has the
It'll look
decimal
like
point in
that.
a different place, and if you didn't,
0.825. Yeah.
okay. So, 0.825 seconds based on this, if I gave you the problem as percent I time, okay, that's 33%. So my I time is 0.825 seconds. That means my E time, I have 2 ways to do this.
You can
Okay,
multiply it
I
by-
can either, because if 33% is I time, that means E
Six-
time is
67.
67%. So I can either multiply
Or subtract.
2.5 seconds by 67%,
Oh.
or I know my total cycle time is
2.5.
2.5 seconds, I can
Subtract it. Yeah.
0.825
Mhm.
seconds, okay? There's 2 ways to do it, but
Mhm.
you're gonna get the same answer,
To get the E time.
okay? So we know that there's zeros there.
Right.
We assume there's zeros there, right?
It's in here. Let me see.
So this is gonna be 75, right? Does that come out right?
Hold on.
Mhm.
8, 2,
Okay, so my inspiratory time is 0.825 seconds. My expiratory time is 1.675 seconds. Usually we only go over 2 places, but just, and those 2, when you add them up, should equal 2.5
Yeah.
seconds. Okay, so there's 2 ways you can calculate that. So that's different than me saying, you know, I gave you a specific I time, okay? So now let's go back. We were looking for a time constant, right? Does this change what I have for my inspiratory time? Does that change what my time constant will be? No, because the only thing that my time constant is going to be on, okay, is my volume, my pressures, and my liter flow. This doesn't change what the time constant is.
Mhm.
But if I gave you different numbers for a pip, different numbers for a plateau, different numbers for liters per minute, or different numbers for tidal volume, then the time, if any one of those changes, your time constant changes, because they're all factors in determining that.
Okay.
Yes, no?
Going through this with you, it's like more understandable, but I know when I sit down for the test, it's going to be like,
So my belief is that I'm a visual person, okay? I like to see things.
Mhm.
I sometimes have to draw it out on paper or put it on paper, do something that is gonna make sense for me. So there's no reason why you can't write on your test. If I gave you a problem, okay, and I'm not even gonna give you values, okay?
No values?
Hmm?
You said no values?
Yeah, I'm just gonna,
Just the words?
sorta, yeah,
Okay.
okay.
So no calculation then?
no, she's talking about now, not the test.
Okay.
Oh, okay.
Too good to be
A
true.
ventilated patient, in the morning, had a plateau pressure of water. You repeat the measurement at the end of your shift. And it is 16 centimeters of water. Okay. So I'm not even putting up what I want you to do with it. Let's just look at this now. I had a plateau of 12 earlier in the day, and now I have a plateau of 16, okay? Already I know that this is more, okay? So if my plateau goes up, and I'm talking about compliance, okay, well, now I'm talking about a number in the denominator, okay? So if I'm going to ask a question about compliance, plateau is in the denominator, okay? If I tell you the peak remains constant, if it was 12 in the morning, my plateau, and now it is 16, and my peak is the same, has my denominator number gotten bigger or smaller?
Bigger.
Bigger. Okay, so let's use the hypothetical number of 5, because 12 minus 5 is 7. If it's 16, 16 minus 5 is 11. So this number is bigger, okay? If this number is bigger and my volume hasn't changed, what's going to happen to my product? My compliance, is the number going to be bigger or smaller?
Smaller?
Right, because, so I don't even, like, you can do it out. So if I don't give you any other numbers but that, I say you all other values have remained the same, okay? Okay. I'm going to ask you, go back to that original, is the compliance increasing, decreasing? Is airway resistance increasing, decreasing? But I'm going to just keep it with compliance right now, okay? All you gave me were these numbers. So I'm going to plug in those imaginary numbers, okay? I'm just going to pick, I'm going to sit down, it's too low for me. I'm going to pick a tidal volume, just some tidal volume. I'm going to use 500,
yeah.
okay? All right. Do it out. Okay, so let's say I know that for compliance I have to have a volume. Here's a volume. I'm going to keep it the same. I know that my plateau has changed. So this one is 12 minus, this one is 16 minus. My PEEP hasn't changed. I'm going to plug in 5.
5.
Okay, let me figure that out. 500 divided by 7 versus 500 divided by 11, right?
Definitely smaller.
This number is going to be bigger. This number is going to be smaller. Okay. The smaller the number for compliance, the worse it is. The bigger the number for compliance, the better it is. 100 milliliters per centimeter of water is a much better compliance than only getting 50 milliliters per centimeter of water, right? So this is where you have to kind of say, well, how am I gonna know that? Okay, because she's asking me about compliance. That's what she's looking for. Well, in compliance, all I have to do is just plug in some imaginary numbers and I can figure it out on paper. Okay? what if I changed this and I said, what's happening to airway resistance? So instead of doing compliance, I want to look at airway resistance. Okay. If that was the problem, what's happening with airway resistance? Well, I go back and I think about my calculation. Write it on your test. What are my formulas for this? Okay. Then all I'm going to do is like, okay, pip minus plateau divided by flow. So everything else is the same. So if my pip is the same, so let me use 20. Here's 20 of pip, and my plateau at this time was 12. And I'm going to divide that by flow. Make it easier. 1 liter per second, okay?
So it's 1.
1 liter per second, which is 60 liters per minute, okay? But now later, I went from a pip of 20 to a plateau of 16. I divide that by 1 liter per second. So I plugged in imaginary numbers, but that's okay because I told you everything is the same. Use a number that's going to be easy for you. That's all, okay? When I do this, this is 8 over 1. When I do this, this is 4 over 1, right? Okay. 1 goes into 8 times 1 goes 4. Okay. So my airway resistance for here is 8 centimeters of water per liter per second. My airway resistance here is 4 centimeters of water per liter per second. Which one has more airway resistance? The one with a higher number or lower number?
The higher.
The higher number. Okay, so if I asked you what's happening to airway resistance, I only gave you 2 darn things, but that's okay, because everything else was the same. That's a word problem. But I'm going to put in imaginary numbers that I can quickly use. Okay, so if you don't remember off the top of your head, put it on paper, look at it, see it, and that will give you your answer.
So what was the question was, what happened to
So
your
a
airway
ventilated
resistance?
patient in the morning had a plateau pressure of 12. You repeat the measurement at the end of your shift and it is 16. All other values are the same. The scenario would continue, okay? Yeah. Then what I would say is, what is happening, what is happening with compliance and resistance? Couldn't I go back to the 1, 2, 3, 4? Increase in compliance, decrease compliance, increase resistance, decrease resistance? That could be the same thing. I just didn't put in a table, right? Because guess what? The volume was the same, the liter flow was going to be, this is the same thing. This is done in a data